With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. The question says that a Young's double slit apparatus has slits separated by 0.28 mm and a screen 48 cm away from the slits. The whole apparatus is immersed in water and the slits are illuminated by red light. Lambda equal to 700 nanometer in vacuum. Find the fringe width of the pattern formed on the screen. We have the Young's double slit apparatus here. There will be two slits. Let the slits be S1 and S2. These two slits are separated by a distance. Let the distance be D. And we have a screen placed here. This screen is placed at a distance capital D from the slits. Now in our question we are given certain values. We are given small d, which is the distance between the slits, to be equal to 0.28 millimeter. 1 millimeter is equal to 10 to the power minus 3 meter. So 0.28 millimeter will be equal to 0.28 times 10 to the power minus 3 meter. The distance between the slits becomes 0.28 times 10 to the power minus 3 meter. We are also given capital D, which is the distance between the slits and the screen, and it is given as 48 centimeter. 1 centimeter is equal to 10 to the power minus 2 meter. So 48 centimeter will be equal to 48 times 10 to the power minus 2 meter. Capital D will be equal to 48 times 10 to the power minus 2 meter. We are also given the wavelength of red light, but that wavelength is for vacuum. Wavelength of light in vacuum equal to 700 nanometer. Now 1 nanometer is equal to 10 to the power minus 9 meter. So 700 nanometer will be equal to 700 times 10 to the power minus 9 meter. This is the wavelength of light in vacuum. Now the whole setup is immersed in water. We will have a refractive index of water to be equal to wavelength of light in vacuum upon wavelength of light in water. The refractive index of water is 4 by 3. We have 4 by 3 equal to wavelength of light in vacuum is 700 times 10 to the power minus 9, and let the wavelength of light in water be lambda w. From here we will be able to find out the wavelength of light in water, which is lambda w, to be equal to 700 times 10 to the power minus 9 times 3 divided by 4. Now we solve this and we find the wavelength of light in water to be equal to 700 times 0.75 multiplied by 10 to the power minus 9. So we have the wavelength to be equal to 525 times 10 to the power minus 9 meter. Now to find out the fringe width, we use its expression. The expression for fringe width is beta equal to lambda Since it is placed in water, so we'll write the wavelength that is in water times capital D, which is the distance between the slits and the screen, upon small d, which is the distance between the slits. Now to find out the fringe width, we put the respective values. Fringe width beta will be equal to 525 times 10 to the power minus 9 multiplied by 48 times 10 to the power minus 2 divided by 0.28 multiplied by 10 to the power minus 3. So this will be beta equal to 525 times 48 divided by 28 multiplied by 10 to the power minus 9 multiplied by 10 to the power minus 2 multiplied by 10 to the power plus 5. We simplify this, we cancel it out by 4, so this will be 7 and this will be 12, and here we will have 75. So beta will be equal to 75 times 12 is 900, and we will have here 10 to the power minus 6. We can write this as 0.9 times 10 to the power minus 3 meter. The fringe width will be 0.9 millimeter. So we have our final answer here. Therefore, the fringe width will be 0.9 millimeter. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.